I'm going to speak about the typical multi-apical deformities. We are going to revise again the apex of the deformity and the cora and that sort of stuff. I want to remind you that the apex of the deformity of the cora is at the level of intersection of the proximal and distal axis. So apparently here, if you just look, we have a cora here. We have an apex of the deformity over there. It looks clear. It's called the obvious apex. And I think it's the real apex too. We draw a first line. The first line represents the distal segment. It's exactly in the middle of the shaft. Then the second line represents the other segments, and they are going to meet each other in the obvious cora, and the obvious cora, it's exactly the real cora. What is the level of the cora or the apex of the deformity? The apex of the deformity can be in the joint, inside the joint, like here, it's inside the ankle itself, or in the metaphysis, or in the diaphysis. This is the obvious cora. You can see it looks like an apex of the deformity. The cora can be in any plane. We have a coronal plane, it's this plane. You can see the coronal plane in the AP view. This is the AP view showing the coronal plane. This is the sagittal plane, if you see in the lateral view. So if you have a deformity in the coronal plane, the varus or valgus, and if you have a deformity in the lateral X-ray, this is the sagittal plane, recurvatum or prorecurvatum. And if you have the deformity in the AP and lateral, that means it's in the oblique plane. It's in between the coronal and the sagittal plane. So the cora can be in the coronal plane, the sagittal plane, or the oblique plane. Again, the apex of the deformity of the cora is at the level of intersection of the proximal and the distal axis of the bone. This is the apex of the deformity. And if you draw the axis or the transverse bisecting line over the transverse bisecting line, this is the proximal anatomical axis and distal anatomical axis. They meet each other in the middle, and we draw the transverse bisector line. Any point over this line is considered a cora. So this is, they are all coras. Again, they meet each other in the middle. We draw the transverse bisector line, and any point here is the cora. If we have uniapical deformity, single osteotomy will be enough to correct the deformity. So this is a uniapical deformity, metaphyseal deformity, as we see here, and you have the apex of the deformity. This is the axis of the proximal segment, axis of the distal segment, the transverse bisector line, and the cora lies here. If we do our osteotomy here, this will be enough to correct the deformity, as you see here. We did our osteotomy, the transverse bisector dime, and we did an open or an angulation osteotomy, or have a perfect mechanical axis or anatomical axis. But if the cora lies outside the bone, we have the proximal axis and distal axis. They didn't meet in the middle of the bone. They met outside the bone. The second situation, we have an obvious cora. You see here, we have an obvious cora. It's crystal clear. But if you draw the mechanical axis of the proximal segment and the mechanical axis of the distal segment, they are going to meet here. This is the mechanical axis of the proximal segment, and this is the mechanical axis of the distal segment. They're going to meet here. The cora is far away from the apparent cora. That means we have another cora. It's not only one. We have two coras. And this is a clinical example. This is a case of achondroplasia, long-standing achondroplasia without any treatment before. And you have this severe deformity. If you draw the mechanical axis of the proximal segment and the mechanical axis of the distal segment, they are going to meet outside the bone. That means that you have two coras. Again, severe valgus deformity, tibial deformity. If you draw the mechanical axis of the proximal segment and the mechanical axis of the distal segment, they are going to meet outside the bone. That means we have a multi-apical deformity. So if the proximal axis and the distal axis meet each other outside the bone, that means you have a multi-apical deformity. We have more than one core. In this example, we have a diaphyseal apex of the deformity. It's clear. Look to the apex of the deformity. It's here in this point. This is apparent coral. And this is the apparent apex or the coral. So if you draw the mechanical axis or the anatomical axis of the proximal tibia and the anatomical axis of proximal or of the distal tibia, they are not going to meet in the apparent apex. They are going to meet away from the apparent apex. That means we have another coral. So this is the apparent apex. This is the real coral. So the coral lies away from the apparent apex. So what's the difference between uniapical deformity and the multi-apical deformity? Why you want to differentiate? Because if you have a uniapical deformity, you need one osteotomy. If you have multi-apical, you have two osteotomies. If you have a uniapical deformity, you can draw only two lines. In a multi-apical deformities, you can have three or more lines. A proximal line and distal line, third or more lines to represent the middle segments of the. So if you have uniapical deformity, we have a proximal axis and distal axis. If you have multi-apical deformity, you have proximal axis, distal axis, and a third line. And this is an example. This is a uniapical deformity. A line representing the proximal axis and a line representing the distal axis, and they are going to meet each other in the bone. You see here. So this is uniapical. But in this deformity, this line representing the proximal axis, another line representing the distal axis. They are going to meet outside the bone. So we draw a third line representing the middle segment of the bone. This middle segment will meet the proximal in the proximal cora and another, the distal axis in the distal cora. So you have two coras. If you have more C-shaped deformity or like a semicircle, you can have more than one middle segmental line. So we have a proximal axis, distal axis. This axis represented this segment, another axis representing this segment, and you have three cores. This is multi-apical deformity. So if you remove the bone, it's very simple. If you have a uniapical deformity, biapical deformities, you have two cores. You draw a third line representing the middle segment of the bone. If it is C-shaped or semicircular, perhaps you have more than one axis to represent the two segments of the bone. Again, if you have a uniapical deformity, the proximal axis meets the distal axis in the middle of the bone, and you need one osteotomy to correct the deformity. But if you have C-shaped deformity, again, you draw the anatomical axis of the proximal segment and the distal segment. They are going to meet away from the apparent apex. This is the apparent apex, and this is the cora. And this is the normal leg or the normal tibia. Again, this is the apparent apex. We draw the anatomical axis of the proximal segment, the distal segment. They are going to meet not in the apparent cora. So we have to draw a third line. This third line represents the middle segment. When we draw the middle segment line, it will meet the proximal line in the proximal cora and the distal line in the second cora. So we have two coras. We need two osteotomies to correct this C-shaped deformity. And this exercise, you see, again, we have two coras, and we draw the transverse bisector line of the proximal segment and the transverse bisector line of the distal segment. And now we have open wedge, and we can correct the deformity. Again, we have osteotomy over the transverse bisector line here, another osteotomy over the transverse bisector line here, and we did open wedge and open wedge. We have shortening, and with this open wedge, we've been able to correct the limb length inequality. You see, we have lengthening here, and we have lengthening over there. And you see the mechanical axis. If you calculate your angles, it's going to be normal. And this is the clinical X-ray of the patient, the clinical photo of the patient. In the sagittal plane, you have the same problem. Look to the sagittal plane, we do the same exercise. We draw the mechanical axis of proximal segment and distal segment, and we do two osteotomies, and open wedge and open wedge. This is the sagittal plane deformity, and this is the lateral X-ray. We draw the anatomic axis of proximal segment and the anatomic axis of the distal segment, and this is the third line representing the middle segment. We have two osteotomy, we have two coras. From this cora, we did the first osteotomy here and open wedge, and the second osteotomy there and open wedge, and you see the mechanical axis or the anatomic axis of the tibia. Again, with the varus deformity, axis of the distal segment, another axis of the proximal segment, and we did two osteotomies to correct the axis and lengthening. So with long-standing achondroplasia and varus deformity, you need two osteotomies because you have deformity of the knee and you have deformity of the ankle. And this is after lengthening and the correction of the deformity. You can use also the guided growth to correct the deformity, because in such a case you have two coras. So we applied guided growth in the upper tibia and guided growth in the lower tibia. Also, another clinical example, if you have anterolateral tibial bowing, you can treat it as an oblique plane deformity because you can see it in the AP and lateral, and you can ignore the site of the bowing here because we are afraid of the development of congenital pseudoarthrosis tibia, and we treated it as a deformity. So we have the proximal axis, distal axis, they are going to meet outside the bone. So we draw a third line. So we are going to have two coras, proximal cora and a distal cora. So we did two osteotomies, and from the two osteotomies, we correct the deformity and we do length. In conclusion, you have to differentiate between uniapical and multi-apical deformities. If the cora lies at the point of obvious deformity in the bone and the joint orientations are normal, the deformity is uniapical. If the cora lies outside the point of obvious deformity, or either joint orientation is abnormal, either a second cora exists in that plane and the deformity is multi-apical, or a translational deformity also exists in that plane. When the cora lies outside the boundaries of the involved bone, a multi-apical deformity is likely to be present. Again, in conclusion, if the cora is not at the obvious deformity or lies outside the bone, second apex of the deformity or another cora or possible translation, need to draw the mechanical axis or the anatomical axis of the middle segment or the third line. You extended the middle segment till it crosses the proximal mechanical axis and the distal mechanical axis.